So, the last speaker of the day, so hopefully you still got some attention. So my name is Claproth. I work for TrendMicro. I've been with TrendMicro for over 7 years now, on and off. I'm a sales engineer, meaning I help our customers, our partners, our sales guys from a technical perspective, helping customers with proof of concepts, testing the products, explaining the products. I'm here to tell you about what we can offer you for security on your workloads, wherever they may run. We call it the hybrid cloud solution, right? So, in your slide deck, you had like kind of similar thing. You see every slide deck. So, in this curve, there's not one customer which is at one point of this curve, right? You might still have physical servers, legacy, old stuff. You have your own data center still, with some VMs running there on any hypervisor. Your desktops might be running physical. It could be virtual desktops. It could be terminal services. We're here at AWS, public cloud, getting bigger, and more. We see it more. And then within that cloud environments, we see a shift in the way applications are built, applications are run, applications are updated through containerization, microservices, or even serverless. Securing all these platforms is a challenge, of course, right? Because you're not running on a single platform. You're running on-prem, you have your physical hardware, you might be running your VMware environment on a hypervisor. You might be running a lot of workloads on AWS. Maybe there's a Microsoft team somewhere. You have some Azure as well. Try to get one single pane of view for your complete security posture of those workloads that are running there. So this is a big challenge for a lot of customers. And if we're talking about workloads in the cloud, I still speak to some customers who don't get this picture. So the shared responsibility model should be on top of your mind, right? So I'm not responsible anymore for access to the data center, the physical hardware, the initial setup of the OS I'm running in my instances, but as soon as I deploy, you're responsible. What about patching? What about the data which is on the machines? What, et cetera, et cetera. So you still have responsibilities to secure these workloads that you're running. And why do you need additional security in the cloud? A couple of reasons. One, already mentioned again, the perimeter is gone, right? If I have my traditional firewall, my traditional IPS boxes, whatever I may be running on-prem in my environment, you cannot come to Amazon with your box. Can I please place this box in your data center? Not possible. And a lot of vendors, traditional vendors of firewalls or IPSs, are slowly making the move into making their appliances virtualized, being able to deploy them in the cloud, but you still have a challenge. The more VPCs you run, the more virtual boxes you need. For an admin, it's a nightmare. So we're talking about host-based security, of course. And there's compliance. So we only mentioned a couple here, but there's this whole stack of compliancy rules that you might have to be audited on, right? We have the GDPR is now there as well. How do you work with that? So these are the 5 components which are very important if you talk about security in the cloud. One is visibility. What do I have running? Anywhere, on-prem, in the cloud, maybe physical service, whatever. I want to know what I have running. Once I know what I have running, I've got some context on these machines, right? So if I have an inventory, I might know a machine name or an IP number or a VPC where it's running in, a tag, whatever. And then I can do some fancy security stuff on that. So, what can we do? So TrendMicro has a solution which is called Deep Security. And Deep Security is a product which focuses on hybrid cloud security. We focus on server workload security. We really differentiate security features that you have to do on an endpoint. So we see a server not as an endpoint like a workstation. We see a server as a completely different workload which needs other kind of security features that you have to put on that machine. So first of all, visibility. How do you get inside of what you have running? So this is a screenshot of the management interface, what we have. And what you see here, what becomes red right now, is what we call connectors. And with a connector, we pull the complete inventory of an account that you add. So you can add an AWS account, you can add an Azure account, you can add multiple AWS accounts. You can add your vCenters if it's on-prem. So you have your complete inventory of all your VMs. And what you actually will get is a complete inventory of everything. Even the machines that are not protected by our software, who even don't have an agent, don't have a policy, whatever. So we can see the machines that are not managed, machines that are not turned on or turned off, how long have they been off, etc. And then a little zoom in on, for instance, the AWS connector. We pull in the complete inventory of your account based on the rights that you have, of course, with the connector that you put in. So once you have the inventory, you have context of all your machines that are running there. As already said, you might have a machine name, you might have an IP number, a VPC, a tag, a folder in vCenter where it's in. There's something you can see from that machine. So what we are able to do, based on the context, is automatically apply security to new workloads. So for instance, we can create, we call it an EBT, event-based task. We see something happening. So what we see happening, a new machine is being created. And with the creation of a new machine, what you're able to do is to bake in the agent within your standard images, or maybe do a scripted deploy of the agent. We will provide you with the scripts, which you can use in your deployment tools like Chef, Puppet, whatever you use. And the agent becomes automatically in the system. So we see the new system being created, and then based on that event, we can say, well, this machine needs to be activated. That means it needs to be managed by deep security. And then we can also say, well, I don't know a lot of context of this machine, so I will give it a base policy. And we have a lot of features which you can turn on and turn off, but just a base policy. Turn on anti-malware without exclusions, for instance. Set the IPS to detect only, whatever base policy which would not get in the way of your workload. And then you can say when this has to happen. I've enlarged it a little bit, and we have all kinds of things where you can set the policy on. So you can say, well, if this machine has the names sql.star and it's in this AWS account and it has this tag, etc., etc., you can set multiple conditions. This task will be done. This is what we call instant on security. So you spin up a new instance on AWS. First boot, it will download the agent, talk to the management interface, and based on the characteristics that I put here, it will get the policy that it needs. And if I demo this, I can demo this later on in the end of the presentation. A very quick and dirty demo, just copy and paste the script in there. Within 2 minutes, the machine is there and it's protected. That's what I'm actually going to show now. So we can integrate this through full automation. So if you still see my screen. So what I've got here is deep security as a service. So we have our software as software, but we also provide it as a service. And here's the computer tab. I see all my machines. So what we will provide for you is the deployment scripts for the agents. So what is my deployment script if I want to run a Linux machine? I want to activate it and give it a base policy. And that's basically it. And the software will tell you, well, this is your script that you will need to run during your deployment. So I can copy the script. And normally you would copy the script within your deployment tools, right? So for every instance that you spin up, this script will be kicked off. But I now copied it, and I will go to my AWS console, and I will spin up a new instance. The Wi-Fi is not that quick here. So I will launch an instance. So this is just a manual process, but of course, normally you would automate this process. So I will choose a Red Hat machine. Then I say, and actually I will paste the script in the user data. So normally this will be on first boot. I will add some storage. I will add a tag to it so I know it's my machine. And then a security group, and just for the sake of it, I will say I'm missing one, I see. Well, review and launch, and I have my key. Where is my key? Well, not very interesting. So I will launch the instance. I see I'm in the wrong region here, so what you will see here, once the instance is created, you will automatically see the machine appearing here, and you will automatically see that it's activating and getting a security policy. That's on first boot. And that's probably within 2 minutes. So I will continue the presentation, and later on you will see that the machine is there and it's protected. Might be here already. Not yet. Normally it's faster. I'll just wait a minute. So I will continue with the presentation. It's always during demos that it's a little bit slower. So, based on the context, I have given this machine a base policy, right? I don't know what the machine is yet or whatever. I want to see, do I still have risks on this machine? So, it's not only that we do anti-malware. So, a lot of people, if I ask them, do you know TrendMicro? Yeah, antivirus or anti-malware. We do a lot of stuff, and we do it very well. So we have 3 layers that we do with deep security. So that's network security, we have system security, and we have the anti-malware part. What distinguishes us from most of the competition is the network security module. We do host-based network security. Because the perimeter is gone, you need to do host-based security, network security. So what we do is intrusion prevention, intrusion detection. We do firewalling, and we do vulnerability scanning. And we all do this on host-based. And why is this still necessary? Because the vulnerabilities are still out there. So there's some old ones here, Heartbleed, Shell Shock, WannaCry is a little bit more recent. But you're still responsible once you deploy your machine on AWS or on Azure or whatever, wherever you deploy your machine, you're still responsible for patching those machines against vulnerabilities. But what is the problem with vulnerabilities? Once they're disclosed, hopefully they get disclosed, right? Hopefully the vendor will get a notice you have a vulnerability, and they have a certain time in which they have to disclose. You have to wait for the patch. And the average time for a patch to be available, any clue? Nobody? Any guess? 2 days? 2 days? That's very optimistic. 60 days, average, for patches to become available. So, in the rule, you're already 60 days behind. And what you see the first 24 hours after disclosure is the exploit kits coming up. They're rising. We're talking server workloads or application workloads, right? So you want to test this patch. Is it in the way of my application? and then you begin deployment, and then you're deployed. Or you might have to do a rollback if it doesn't work. What we can do for you, and we call it virtual patching, basically it's host-based IPS. So we can run a recommendation scan on your machine, and that recommendation scan will check the operating system, it will check which applications are installed and which patch level it's on. And we will give you a recommendation on what rules to apply to that machine only. So normally if you do IPS on the parameter, you won't make a rule set per machine. That's like an admin nightmare, right, to do. This is an automatic system which does the recommendation scan for you. And in the rule we have within 24 hours after disclosure, we will have an IPS rule against the exploit. So if a vulnerability is disclosed and is network detectable, within 24 hours we will have a rule in our system. This is a virtual patch, so it's just a rule which inspects network traffic. So you don't install any software. So if a rule might screw up your application, it could, right? So if you have for instance, you have a SQL application and the application needs cross-site scripting. If you turn on the rule to stop cross-site scripting exploits, your application will die. So what you can do then is put that rule in detect-only mode. We will report you on that there's cross-site scripting going on, but we won't stop it. Or you just can turn off the rule. You don't have to do a rollback. Of course, this is not a replacement for actual patching. You don't want the rule set to be too big. So once you have patched your machines or applied a patch and you will run the recommendation scan again, we will recommend to unassign the rules that are not needed anymore. So here's a screenshot of the recommendation scan, and you're able to say any recommendation you find, automatically apply it. So for production, high available workloads, never set this to yes, of course. You never know what's going to happen, of course, but you can test it in your test suite and put it there, put it on yes. Or if it's in a way, put the engine in detect-only mode. So you're protected on a network level. So what else can we do? I always call it the tick in the box. You need this, right? So a couple of years ago, there was some high-level people in the IT saying antivirus is dead. No, it's not. It has changed. So the threat landscape has changed. So malware antivirus scanning is not antivirus scanning you used to know. It's multi-layered already. So we have our famous slide, I call it the funnel of TrendMicro. What we will do with antivirus scanning or anti-malware scanning, this is the traditional way of scanning. We have a signature, we call it a pattern. So it's basically the database with all these bad files and the good files. So it's a very fast way to make a shift of what's good, what's bad. But with the new threats, you never know. There's a big gray area. So we added some layers within the engine of our anti-malware scanning. So there's machine learning. And machine learning is nothing else than an algorithm. An algorithm is software that learns, and it learns from a data set. And this year we exist 30 years. We just had a big celebration with the company. We've been collecting threat data for 30 years. So our machine learning engine learns on a data set of 30 years of threat intel. Still there's a gray area. It might get through. We can do behavioral analysis on files or on executables or whatever you might want to do. So when I double click a PDF file and within 2 seconds an encryption process starts, that's highly suspicious, right? So we might kick in. And then we have a last resort. It's a different solution from TrendMicro, but we were able to do custom sandboxing. So if you really don't know, we have never seen the file, it's not signed, it's the first time in the world this file has been downloaded, comes from an unknown IP address or whatever, we are able to send this file to a sandbox. And we say custom sandbox because we have an appliance that you can put on-prem where you can import your own images that you use. Because if I'm an attacker and I want to attack a certain company, I will do my homework. I want to make sure that I'm in that company. So I will say, as an example, a Belgian company. My malware won't kick off when I don't see an AZERTY keyboard installed. Right? So that's why we do custom sandboxing. You can import your own corporate images. So we will kick the malware or the possible malware up in the sandbox of your own environment. So that's the tick in the box, malware, right? So we have network security, we have malware security, and then we have system security. And with system security, this is really server workload focused. So we have application control. Normally, application control on an endpoint is whitelisting and blacklisting of applications. What we do here is very different. This is server lockdown. So we build a baseline based on, this is my server, it's good now. We will build the baseline. Anything out of the baseline will be denied. This is, don't turn this on a server which has 40 functions, right? Of course, this is all API driven if you want to put the server in maintenance mode to update your application, etc., for the DevOps guys. But it's pretty strong feature you can turn on your workloads. We have integrity monitoring. Is my workload still the workload that I want it to be? So what we can do, we can set rules on certain files, folders, registry settings, configuration files. And if they change, we can alert you on that. So a standard rule that we already put in, keep an eye on the host file. The first thing a bad guy wants to do is change your host file to pass DNS or whatever. And then we do the log inspection. And with log inspection, we have standard rules already for Windows systems, for instance, every Windows event. For Linux systems, the standard alerts that can be in the logs. And you can put your own severities on those events to be alerted on it. But we're also able to pull information from custom logs, from your custom applications. So if you see X, Y, Z in this file, alert me on it. The other thing is that we can, with log inspection, we can be a man in the middle for logging to an external logging system, like SumoLogic, for instance. A lot of custom applications are not able to forward their logs in native format in Ceph, Leaf, whatever you want, whatever you're having, SNS. So we can be the man in the middle for that. We can read the custom logs and forward them to the other systems. And then there's the vulnerability scans. So normally when you do vulnerability scanning in the old-fashioned way, you have an appliance called Qualys or Nessus or whatever Rapid7, whatever you're using, and you throw that at your environment, and it does port scanning and it does all kinds of stuff. Try to do that from the outside on your VPC in AWS. You're not allowed to officially. You need permission. You have to ask them, and you get permission for a certain amount of time to run your vulnerability scans. So as I mentioned, we do recommendation scan for the IPS stuff. That recommendation scan will give you a complete list, and we can do reporting on that, on which vulnerabilities you have open on your machines. And then we can also take action in closing them with our IPS rules. And we can schedule those, of course. Docker support. I came in late today because I just had a 2-day training on Docker. I was coding all day. But we have Docker support. So if what we see happening now, not only in the cloud, also on-prem, but everybody is transforming their monolithic applications into microservices. And how do I secure my microservices? And we have multiple things that we do. So we can protect your Docker hosts, of course, but we see your Docker containers running on those hosts. So what we can do on the container is malware scanning and also the IPS part. So we do the recommendation scan, vulnerability scanning for your Docker containers. Because you might have pulled up a container with a vulnerable version of Apache and you don't know. This is a sample of the dashboards that we have. Everything is web-based, dashboarding, but we also do reports, of course. But you have a single pane of view for your complete environment. It might be on-prem, it might be in the cloud, workloads running everywhere. That will give you a lot of freedom in which platform you are going to choose for running your workloads. You might say, well, I have still something on-prem, and I'm going to do my test dev in AWS, and I'm going to do wherever, anywhere. So you have a free choice. And this way, it's very easy to accelerate your compliance with the way you want to work in the future, right? Cloud is moving fast, moving quickly. So you're running your workloads, you're moving your workloads, and then you find out, I might be going from workloads to platform as a services, or maybe software as a services. So you're moving fast. So you have to move with the slowness of the, this is an automatic slide. And if you look at the Sun's top 20 critical security controls that you need, this product fills in 14 of those 20. And why? You might say, why only 14? There are some stuff in there which is physical access, etc., etc. We're not responsible for that, of course, as a software company. What we talked about so far is runtime. Workloads that are running in your environment. And we can do all the fancy stuff. What about pre-deployment? Because you already had some DevOps slides. I have some as well. DevOps is the buzzword. It's going on. So what you want to do is you scan your images before you deploy your images. Why? DevOps is a good thing. The modern developers are good guys, but they have their own way of developing. They have their own preferred images that they use. They pull from anywhere on the internet and put that in your registry and use that to make your applications, right? That can be very dangerous. So what we're doing here is making a shift left. So from runtime, going into pre-runtime scanning as well. And we have a product which integrates with deep security. It's called Deep Security Smart Check. And what we do, if you look at the CI/CD pipeline, we actually can, anything that is getting pulled into your registry, we can scan it for malware and vulnerabilities. And we integrate with all kinds of tooling that you're going to use for your DevOps, like the Jenkins and the GitHubs, etc., etc. So it's continuous scanning of your registry, and we will show you which machines are good, which containers are not good, and we integrate with the standard DevOps tools that they use a lot, like Slack or whatever, ServiceNow. So this is what we do. We hook into the CI/CD pipeline without interfering with the DevOps. There's nothing, so talking to a dev guy, say the word security, and he goes, ooh. They don't want it, right? So, and this is seamless integration for them to check if everything is safe. Because everything is API driven. We call everything through APIs. I have a small demo of a Smart Check because it's a pretty new product of us. And I hope I have sound as well over HDMI.
Deep Security Smart Check delivers pre-runtime scanning of Docker images, allowing image-borne threats to be remediated prior to deployment. With vulnerability assessment and malware detection, Smart Check can be integrated into your CI/CD pipeline to provide automated scanning of Docker images without negatively impacting the ability for DevOps teams to deliver production-ready applications. After logging into Deep Security Smart Check, you are presented with the Smart Check dashboard. The Smart Check dashboard surfaces information that is important to DevOps and system administrators by providing an overview of the information collected by the system. Smart Check provides scan coverage metrics to identify how many of the images are eligible to be scanned, as well as how many images have been scanned. The dashboard provides a breakdown of vulnerabilities within all images being scanned by category, and provides a simple visual indication of problem areas. Smart Check identifies malware and indicates the number of viruses that have been detected and configured to be scanned. Additionally, Smart Check provides further statistics which include the total registries that the system is configured to scan, the total repositories within those registries, the total images, and the number of scans that have been conducted in the last 24 hours or the past 7 days, which gives you a good indication of what the system has recently scanned. Smart Check allows you to configure a view of the scans. The view provides a means to organize scan results from a variety of registries into collections that can be easily navigated. The collections are defined using a filter that matches against any segment of the image path. For example, you can create a view that brings together the scan results for all images in your specified registries that have a tag name such as latest. A view will let you see the scan results for all images with the associated tag label called latest across all your registries. Within the view page, SmartCheck displays information similar to that shown in the dashboard. The information presented refers only to the images that are captured in the view. Now let's see one of the ways a scan can be invoked. Deep Security SmartCheck has a rich API collection. This allows other services in your pipeline to trigger scans and process scan results automatically. Let's invoke a scan using this event model. In this scenario, a developer is tasked with updating the logo on an online web photo album. The developer uses Git to copy in the new logo and then commit the changes. When the developer pushes the code changes to the remote Git server, Jenkins detects the change and starts a build. The build module creates a Docker image and pushes it to the Google Cloud Registry. An integration component has been set up to receive a notification from the Google Cloud Registry when an image is pushed to it. The integration component then triggers a scan by calling the SmartCheck Scan API. The page can be reloaded to see if a scan has been started. You can see a spinning icon next to the image that was pushed to the Google Cloud Registry. This indicates that a scan is currently running. While we're waiting for the scan to finish, let's look at the layout of the vulnerability findings for a different image. The findings provide summary information on the scan that was performed and the vulnerabilities that were found. Vulnerabilities are grouped by their severity. Because this is a Docker image, SmartCheck breaks down the contents of the image by layer. Layers within vulnerabilities are shown with a visual cue of a lightning bolt next to them. When the layer is expanded, you see the vulnerabilities it contains broken down by library. For each vulnerability library, the information about the relevant CVE is presented. SmartCheck provides the version of the library which contains a fix for the vulnerability, and this makes for an actionable vulnerability result. Looking at the scan history, we can see if a triggered scan is complete. Now that the scan is complete, a notification appears in your collaboration tool, which can be set up using the webhook API. This notification includes the image scan results, the scan details, and detected threats. Let's take a look at the scan details through the Slack link. Malware is identified by a visual treatment that is common to deep security products. Again, the image is broken down by layer. The layer that contains malware shows both the malware found and the path to the malware in the image. This provides DevOps with the ability to mitigate the threat prior to runtime. To learn more about Deep Security SmartCheck, visit trendmicro.com/smartcheck.
Goed. Wat slecht te verstaan, het filmpje weer even nagezet. Wat we dus eigenlijk met SmartCheck doen, is zorgen dat al de images die binnen worden gehaald door de developers, bekeken worden, gescand worden en geanalyseerd worden. En dan kan een verdict uitkomen. En dan kan je ook nog thresholds gaan zetten. Als die maar één critical vulnerability heeft, mag die door. Heeft die 2 high severe? Oh, sorry. Switching to the English. So if it has, so you can say if a machine has one not so severe vulnerability, it can pass through production. If it has one severe vulnerability, it cannot pass. Right? And then, but this does not sit in the way for the developers, right? And if you're talking about cloud and DevOps, we're talking about automation, right? If you have to do something twice, I want to code it. So both of those products, so Deep Security and Deep Security SmartCheck, have very rich APIs. I'm not a coder myself, but now we have this since a year. We have our automation center. And it's a web page, and actually I'm able now to write scripts to do API calls, etc., etc. It's very easy to do. So it's a page that we have. You can Google it, and you come into the page, and you can look up the API reference, and you just can click, I want to see from my computers which computer has which policy, blah, blah, blah. Oh, and you will get the sample code, copy, paste, done. Right? I don't have to go through a 500-page book to find the reference for this call or API. So this is very, very nice. And you can test your code, of course, with Postman or curl. And what we also have is a GitHub page. And we have customers that build very fancy scripts, and they gave it to us so that you can submit scripts there. We test them, and these are all supported scripts. If you look good, there's already a guard duty script here. So Amazon Guard Duty will give you information. Do you have any vulnerabilities in your environment, right? It doesn't take them away. So this script will kick off the recommendation scan for this instance, and we will put the IPS rules on the machine automatically. So Guard Duty finds a vulnerability. We kick off the recommendation. Is it there? Do we have a rule? We will put the rule on it. Full automation. So you have security, and security comes with events and alerts, etc. And you want to do something with it. There's more than one logo on this. But that's why I said we can be the man in the middle for logging, right? Not every application is capable of native logging to an ArcSight, a Curator, or SNS. We can use SNS as well. So we can be the man in the middle for that logging. And there's a very fine example how we can do integration with this without doing API calls or difficult stuff. This is not even a feature from the product. This is what you can accomplish if you use the AWS Web Application Firewall, for instance. So an attacker is attacking one of my machines. What I will see as alerts is hundreds of firewall events or IPS events coming in from one machine. So those will all be logged to our system. We can say forward all the logs to SNS, right? And I can write a Lambda function which keeps an eye on that. And if he sees a certain threshold on IPS hits on one machine, I can say to the Lambda function, block the source IP on the WAF. This is something which is not a feature of our product. This is just an example of how easy it is to integrate if you have the right tooling which is cloud native. And Deep Security is a cloud native security product. Support for OSs. So I've looked it up. Deep Security is the product with the most supported OSs for security, for antivirus and IPS, etc., etc. We have a lot of legacy support for on-prem. We still support Windows 2000, actually. But we support a lot of Linux kernels. Currently, it's 3,900 Linux kernels that we support. And our kernel retention is about 24 hours. So if a new kernel comes up, we try to have support for it within 24 hours. I don't think you can update your kernels that fast if that happens. So how do you use this product? So you can use it on-prem, but we're here at AWS, but this is software that you install, you buy a license, etc. But we have it as a service. You don't have to set up anything. You just create your account, put your AWS account in there or your Azure account, you're done. Or marketplace. So from the marketplace you can deploy Deep Security, and automatically to Deep Security managers, a load balancer, a database, etc. will be deployed through a CloudFormation script. And you can use consumption-based billing. So you're only paying for a machine that is turned on, has an agent, and has a policy per hour. So why would you choose Deep Security? There are multiple reasons, of course. You need security, you need extra security in the cloud. One of the unique features, of course, is the host-based networking security, the IPS, IDS firewalling. Audit evidence, compliancy, etc., etc. There's a lot of reasons why you might need a cloud-native solution to protect your cloud workloads, wherever they might be running. So if you want to know more about this, and I think actually this movie is on the same page. If you go to trendmicro.com/AWS, you find all the information that you need on this product, but more than just this product, of course. The integration, the GitHub, the automation center, etc., etc. So do you have any questions? No questions? And I want to thank you.